Hey everyone, thanks for joining us. Have we done the demo yet, or no? We have not. Okay, cool. Sounds good. Okay, so let me share the slides. Uh, Sandy, do you have the link to those slides? Okay. Okay, perfect. Awesome. So in this workshop, what we're going to explore is basically how to build AI applications using GraphQL. So basically connecting your LLMs to your data using GraphQL and checking out the limitations to that approach. And then this new approach that we have come up with called PromptQL, which is basically giving LLMs a programmatic runtime and a unified data query layer. And make them write the code to fetch the data they need and process the data in a programmatic runtime and not in their context, and get much more powerful performance out of them. So that's what we'll explore. Before we dive into that, how many of you are familiar with Hasura? Okay, one person. Okay, awesome. So Hasura is basically a developer tool that allows you to build instant GraphQL APIs on your data sources. So connect your data sources to Hasura, and Hasura will instantly give you a GraphQL API on your data sources. No need to write a backend, no resolvers, nothing. So we have this concept of a supergraph where basically this is like a unified schema of your domain, and you access data through the supergraph using GraphQL for your or even REST for your applications. Now, what if we could also use this concept of this unified data query layer, but for LLMs? So we tried both with GraphQL, but then realized this approach with PromptQL was much robust. And I will walk you through PromptQL in a demo. But what I want you to start doing is start setting up setting up one database and start running a GraphQL API on it, and then let's connect it to an LLM and see how it works today. So let's start with that. So does everyone have these instructions? Either you can scan the QR code or the short URL, either works. Okay, and I'll also do this on the big screen so that you can, for those who don't have a machine, can just follow along. Sunny, do we have a different device where the demo app is running with Zendesk and everything? Praveen, is it running on your device?
The demo, right?
Yeah. So we'll show it towards the end, like with a bigger use case. Yeah. Okay. Awesome. So here we all are. So make sure that you have Docker installed on your machine and it's running. And also, whoever is following along, do you have a Anthropic API key? You do? Okay. You have an Anthropic API key?
No, but it's my company's computer. I'll just follow your screen. Yeah, I can't.
Okay, you can't do the workshop. Perfect. That's okay. Awesome. So let's start with basically installing Hasura. We're using Hasura just so that we can quickly build a GraphQL API over our data sources. We don't have to do a lot of work. So I'm going to open a terminal, close these old ones. Okay. Okay. Let's do, is there the workshop? Okay. Let's create a new, okay. So let's start with installing Hasura's CLI. Just log into Hasura. Okay. It logged in. Just in case it did not for you, uh, you might have to create an Hasura account. Feel free to talk to us, like ask me any questions. And there's also this link at the end. This link, we have our engineers standing by on that call. So if you have any questions, any doubts, you can just go there and ask. Okay. So now that we have logged in, let's create a new project. I'm just going to use the same name, your project name. And we initialize a supergraph. Okay. Now what we'll do is connect a database to our supergraph. So we'll connect a Postgres database to our supergraph. So I'm going to use Postgres. Any port is fine for now, 1993. And if you have your own Postgres database hosted somewhere, feel free to use that. Or I have this sample data set here, which you can use. Okay. Now I'll just introspect my data so that the schema is built in my supergraph. This will add all the models to the supergraph and relationships. Okay. And let's build the supergraph. Any questions so far? Is everyone able to follow along? Yeah? Okay. So let's build the supergraph. Okay. And so let's just enable the SQL interface as well. So GraphQL is enabled by default. But you can also talk to your supergraph using SQL. So let's enable that because that is how PromptQL talks to your supergraph. So let us in the end.engine file, let's just add this flag. Enable SQL interface is true. And I'm going to make this even bigger. Okay. And let's run the server, the API. So let's just make sure Docker is running. Docker is fine. Okay. Okay. So our API is already up and running on our Postgres database. So now let's create a very quick backend for our AI application and connect this API to our LLMs and test that out. So for that, let's clone this repo. Oops, I shouldn't have done it here, but it's OK. OK. And then go into that repo and make sure you have Poetry installed so that we can install all the Python dependencies. So the instructions to install Poetry are there. But since I have Poetry installed, I'm just going to install all the Python dependencies. There you go. And let's start the AI server. Oops. Oh, I already have my API key in the. I already have the API key in my Bash profile. So OK, perfect. So we have our AI server running on localhost 5555. It's connected to our GraphQL API, which is running on 3000/GraphQL. So let's see how it works. So let's log into our UI. And here we'll just tell it that we are running on 5555. Okay, perfect. So now, quick look at the data that we have here. So basically, this is assume you are an enterprise company, you have a product, you have some users. So this data basically has your users' data, their product usage data, their billing data, invoices that you have created for them, things like those. So that's the data it's connected to right now. So I can ask something like, what are the top 5 invoices? Something like this. I'm gonna make this bigger. Okay. So it'll try to query it. We have given this capability to retry it if it fails somewhere. So okay, it gives me that these are the top 5 invoices, 999, 998, 97. And this is the GraphQL query that it ran to fetch the data. And this is what it got. But now let's ask a more complicated query. Let's ask something like, who are our top 5 customers by revenue, let's say. This data is not directly available in the database, but we have all the invoices data, right? So we can group the invoices by the user ID, sum it up, and see who are our top customers, right? So let's try to do that. Who are our top 5 customers by revenue? Look at the invoices. Let's maybe do that. So what it's doing is, it says I need to query the invoice data, sum up the amounts for each project, and then rank them. Okay, that makes sense. So what it's going to do is fetch the invoice data. There are so many invoices that, one second, hold on. Yeah. So now it fetched all the invoices, gave all the data to the LLM, and the LLM is trying to sum up whether to find out who are our top customers. And this is nowhere close to the right answer, because if you give it a bunch of data, it's like hundreds of rows of data, and then ask it to find the customers, group them, sum, and then find me who are the top 5. LLMs can't do that. LLMs can't even count the number of hours in Strawberry, right? So this just completely hallucinated the response and giving me some fake data. Now let's try the same questions, but using PromptQL, and then I'll walk you through what PromptQL really is. So to run PromptQL on your end, what you'll do is go back to your terminal, open a new tab, and instead of running this, running the AI server on the GraphQL API, run the AI server on the SQL API. So wait, I already have my Anthropic key, so I don't need that. Okay. Okay, so I have PromptQL server running on 5556. So I'll go back to my UI and just do this 5556. And just start a new chat. Okay. Let's ask the more complicated question. Who are my top customers by revenue? Maybe do 5, or maybe just give an open-ended question. Top customers by revenue. Look at the invoices. Now, if I ask this thing to PromptQL, so basically what PromptQL is giving your LLMs a programmatic runtime and a structured unified query language for them to write, and then access the data that they need. And then this unified data query layer can translate this structured query language, which is SQL, into any underlying query of the underlying data sources. So underlying data sources does not matter. It could be a SQL database, no SQL database, an API, anything. But the interface with the LLM is Python plus SQL. Because they understand, they can write Python code really well, and they understand SQL schemas, and they can write SQL very well. We do this deterministic translation of SQL to any of the underlying data sources. So it gave me the right answer. And this is the right answer, which is 31,000, 25,000, which is not the same as what we got with GraphQL, which is 2,700, 2,400, because it's trying to hallucinate something on the in the LLM's context. So yeah. So now let's look at the prompt query generated. Again, if it ran into some error, it fixed itself. Let's say, okay, it was trying to use pandas, but pandas is not installed in its runtime, so it did not use it next time. Okay, so this is basically what's happening in prompt QL. So it's writing a Python code, writing this SQL query for itself, and executing this SQL query to fetch the data. Now it fetched the same data, which is all the invoices, but what it did was this group by on user, and then sum the invoice amounts individually to find which user has the highest revenue. It does all of that in a programmatic runtime. So if you see here, where is it? Yeah. So you see that it's doing the summation of all the different invoice amounts in a programmatic runtime. So you were sure that it will never hallucinate any data processing question, because it writes code for it. So it behaves like an analyst and not like just an LLM which can generate text. So this is prompt QL. So this is the query that goes back to the prompt QL server. Comes back with an answer. Another interesting thing is it saves whatever it works upon, whatever this information knowledge that it has created. It saves that in something called a structured memory artifact. You see, it's doing executed.store artifact. So next time if I ask a follow-up question, it does not have to figure anything out from the LLM context. What it will do is retrieve the information from its structured memory artifact. So now it can store thousands and thousands of rows of data in its context because it's in a structured memory and not in the LLM context. Because LLM contexts are prone to hallucinations, right? So now if I ask any follow-up question on the, okay, let's something like, which projects has the third user created? Something like that. Let's see if this works. Okay. So we have all the projects created by the third user. They have created 10 projects. We have all of them here. And again, this is what's super interesting is it did not try to remember what the customer ID was. It is not looking at its own context because it's extremely prone to hallucination. It knows that. So all it's doing is it's getting this artifact from its structured memory, getting who the third user was, and then running another query for the projects created by this specific user. So this customer IDs, email IDs, things like those are never passed through context. So there is no scope for hallucination. Everything is happening programmatically. You get the data, you get the response back, and next time, just in case if it needs to refer to these users' projects again, it just stores that in its memory again. So this basically shows the power of prompt QL, where if I even try to ask this question to GraphQL, I don't, let's see. Yeah. Which projects have, maybe the context is very small here, so maybe it will still work, but let's try. Has the third user created? Now you can argue that we can do all of these things by adding aggregates and stuff like that to GraphQL, to our GraphQL API, sums and joins and things like those. But that will bloat up the metadata, the schema, and we tried to fit that schema into an LLM prompt. It just runs out of context windows. So let's see. Users limit 3 order by ascending. Okay, sure. Again, if I give these capabilities to GraphQL, it will just bloat up the schema. Will not work. I'll let it figure it itself out. But so this is basically prompt QL in action. Now, yeah, I think exception raised by LLM. I think LLM must have said, yeah, prompt length or maximum tokens. So if you're trying to pass everything in the LLM context, it just does not work. So the best way is to reduce the amount of context that is going to the LLM by doing everything programmatically, most of the things programmatically. Now, this is a simple example on one database. Yeah, question.
So rather than asking everything to context, have you folks tried fine-tuning the model offline?
Fine-tuning on what, though?
So basically, like you have a bunch of data in your Postgres database, right? And you use the model with an SFT technique, basically, and say, hey, here is your exact things that you can actually still load all the things that you're talking about, there, right? Then your prompt or the context that you're really passing to it will be minimal at that point, right?
So so for every use case I will fine-tune a new model. Is that what you're saying?
For every data source you have.
For every data source I have, and so me as an enterprise company, I have 20 different, maybe 200 different data sources. Some are SQL databases, some are NoSQL databases, some are APIs, things like those. All of them connected to some GraphQL API. All of them are exposed via GraphQL API. Then I have each of my customers has different, let's say, databases, schemas, and things like those. Do I fine-tune a model for each one of these use cases? It's extremely expensive, and then what if my schema changes? Do I fine-tune the model again? So you see how quickly it'll get outdated, how expensive it'll get, and it still will not solve for the problem of doing complicated data operations, because LLMs can't do that. Like mathematical operations, they can't do. If I want to call a downstream service, let's say I want to ask it to connect to Zendesk, fetch some tickets by a customer, summarize those tickets for me, and classify whether they're important or not. All of this happening in the context will keep on bloating up the context. But ideal way would be to use a downstream LLM just for the summarize task, just for the classify task. Just keep it very modular, right? In a programmatic approach, it can write code for itself and call downstream LLMs or whatever it needs to do, just like a human analyst would do. But if I just give a massive API, fine-tune a model on it, it'll still not be able to do that. So now let's look at a bigger example. Let's take this example, the Zendesk example that I just took. Do you have the demo running, Praveen? Okay, I'm going to switch over to. Okay. Okay, thanks, Praveen. Okay, so this is same thing that you just built, but this is connected to our. So basically, it's product data in Postgres, but also it's connected to the Zendesk API. Zendesk is where all our customer support tickets lie. So this is a tool we built for our internal customer support team. So I can ask some questions like, let's start with a similar question. Who are our top 5 customers by revenue? Yeah, look at the invoices. Okay. Okay. Top 5 customers by revenue. Yeah, same numbers. Similar prompt QL generated and a text summary out of it. Okay. How many support tickets do each of these customers have? Okay, let's do that. So now it has to do a join between the data it just pulled. It knows the top customers, but then support tickets are present in Zendesk, so it has to figure that out. So let's see. Oh, these customers haven't. Okay. Look like they have no tickets. None of our top 5 customers have any tickets. Okay. Look at the next 10 customers and see if they have any tickets. let's try to do that. So imagine a very natural conversations to all your SaaS apps. So we have built a tool on GitHub for our engineering team. And you can ask some very sophisticated questions to it. Things like, for this, let's say I raised a new PR, right? Who should I assign this PR to? So it will look at, OK, what files have been changed? For each of these files, who has made most of the contributions to these files? Probably they are the best person to review this PR. Things like those. OK, what issues have been created in the last 10 days? Can you classify them as important or not? And then for the important issues, can you add a label called important? Something like that. So sophisticate things like take action on your data. OK. So next 10 customers by revenue. Let's see. It got next 10 customers by revenue. Please tell me one of them has a ticket. Okay, neither have. OK, let's just fetch tickets directly. What were the last 10 tickets created? While it does that, it'll still show you how it's trying to do this join between, so how it's calling this Zendesk API. So you see, to the LLM, it seems like a SQL function call. But under the hood, the API which is connected to Hasura's DDN, it is Hasura's unified data query layer. It's translating this SQL function deterministically into this API call. So to the LLM, it looks like SQL, but actually what's happening under the hood is an API call. OK, so last 10 tickets. We have the last 10 tickets. OK, perfect. So we have the last 10 tickets. Perfect. So let's do summarize these tickets. Maybe fetch the comments on these tickets first. Let's do something more complicated. Fetch the comments on these tickets. Summarize these tickets plus comments. Then categorize each ticket as important or not. Maybe as very important, somewhat important, or not important. Let's do that. OK, let's see how it handles this very weird, complicated query. Imagine doing all of this with the GraphQL API. OK, so let's see what it's doing. It's getting, so for these last 10 tickets, again, remember, it's not trying to remember any of the ticket IDs or anything. It's always querying its structured memory. So you can be sure that there's no scope of hallucination. These are the last 10 tickets that you were looking at just now. You get the comments for each of the tickets. Then, see, it's calling a downstream LLM. It is giving it a prompt. Let's summarize this support ticket and its comments, focus on the main issue, any solutions proposed, and the current status if apparent. Then, it's calling another downstream LLM with this prompt that categorize the support ticket based on its importance, consider factors such as the severity of the issue, potential impact on the user's work, and the urgency of the problem. See? And then, so it's creating its summaries. It's it also defined the categories to classify, like very important, supportable, not important, based on our prompt, and classified each of those tickets as well. And let's see, summaries and importance of the last 10 tickets. See, proper summary, 2 of these tickets were like dummy tickets, so insufficient information was provided. And very important, not important, not important, suboptimal. So see, imagine how much will it improve the workflow of any real users. Now this approach takes these AI applications from being like these cool Twitter demos to being actually useful in your enterprise use cases. So we are first building the internal tooling out for our customer support team for our engineering team with the with GitHub connectors, for our sales teams with Salesforce connectors, Clary connectors, and things like those. And eventually we HR team with rippling and stuff like and products like those. And then eventually all of you can also start building really, really powerful AI applications out with your own data using PromptQL. Any questions? Thoughts, comments?
Have you seen hallucination in the SQL generation?
Yes, if the SQL schema becomes insanely big, so when you have hundreds and hundreds of tables, then yes, it is sometimes prone to hallucination. So we are working on figuring out how to basically limit the scope. So basically, how do you pass massive schemas? This schema by design is much smaller than a GraphQL schema, so it already performs much better. But for, let's say, when I have 1,000 different data sources connected and I want to create a huge AI tool, that's when it can get out of hand. So we're figuring out how to do basically how to pass subset of schemas, how to do prioritizing of what tables and columns are relevant to it. During design time, what we can do is like we can just have a priority of the models in the schema. In runtime, what we can do is some heuristic ranking based on what the user's context is, and then what the different models are available in the schema, and then do some heuristic ranking, and then just pass that subset of the schema instead of the entire schema. So we are taking those approaches out, but for I would say 95% of the applications, it's perfectly fine. For those 5% massive applications, yeah, we are running into those issues.
Or do you prepare some code and Git like tweet?
It's yeah, I get your question. So it's well prompted. But it's completely prompted. There's no fine tuning here. So here we do tell it that you are this helpful tool who can write Python code. You can write SQL to access data, and you have access to other LLMs to do summarization and classify tasks. So you have to tell these things to it, so that it's aware that I can take these actions, right? So like basically, whatever services functions are available to you, you just need to know. So that's what we tell it. Yeah.
Quick follow-up, is that zero shot or few shot?
Oh, it's few shot. It's not. Okay. So we haven't like a proper full complete Python code we haven't sent. So in that way, it's zero shot. But this, when you say, so like in case there is a summarization task, use the summarize perimeter, which you can use by doing something like this. So examples like snippets, so they are few shot, you can say. But like entire piece of code, no, because it's just like Python code, write Python code. That's all.
I'm a note in, I'm just wondering, is this like provided by you, we cannot modify it, or is there any way we can customize the make some changes?
Yeah, so best part, because it's completely prompted, right? There's no fine tuning. So LLMs are hot swappable, right? So here, if by default, when I was running the server, oh sorry, this is yours. When I was running the server, I could have given it the -- LLM flag, and then we support OpenAI, Anthropic, Llama, but eventually we want to support every single LLM because it's LLM agnostic, right? Yes, certain LLMs will perform better. In our testing, Anthropic performs the best. That's why we are using Anthropic. But OpenAI works pretty much very similarly well. But you can use any LLM essentially.
Okay, so we basically can choose which we use, but we cannot modify the we use.
You cannot modify, sorry, what?
We use like, I'm not so sure about that. I know nothing about just, we cannot change the coding and make do something differently. Like for example, we don't like our users to do certain operations. Like we don't want our users to know what's the most time 4 tickets credit. So we want to ban our user from doing that. Is there any way we can do that?
We want to not allow them to do that.
Yeah,
You-
we don't want them to.
Oh yeah, so Hasura as a product has very fine-grained access control authorization rules. So you can define authorization not just at a model level or at a column level, but at like a row level, at an entity level. You can define authorization rules. So very robust auth rules. So and because LLM is directly not touching your data at all, right? There is this data query layer in the middle, which is which has Hasura's auth. So LLM, you can restrict whatever access you want because of this. Yeah, that's a fair question because, but this is the fun, like step one for any enterprise use case, which is auth needs to be robust.
Okay, just ban the query. Okay.
Yeah, it won't even have, so you, like, even even for the schema you can define, right? Like it won't even know that this kind of data even exists if the user's authentication doesn't have access to that.
Okay. Also, I'm curious, like your demo, it works pretty well, like how it's integrated with GraphQL. I'm just wondering if something doesn't work out. I mean, when I'm doing my projects, like for example, some queries that doesn't really work out, how do you troubleshoot? Is there any logs or is there anything we can troubleshoot? Do you have demo to show us?
Great question. This I'll have to ask my, okay, maybe I should go back to that. But I'll get back to that as on that system. I want to show one more thing, which is, let's do something like, get me the latest project, maybe something like that. Just want to show you the capability to take actions using LLM. So not just read information, but also take action using an LLM tool. And then also, if you're taking action, you do not want to give your LLMs free reign over your data, right? Because what if they change something without your understanding or knowledge? And that's very risky. So latest project, we have the latest project. Okay, perfect. So let's do something like issue $20 in credits to this project. That's action. So you don't want the LLM's free reign. Like, what if it hallucinates 20 as 20 or 200,000? You're out of money. You don't want that to happen. But if the data query layer, if it recognizes it's making a mutation, if it's making a change, if it's a create, update, or delete request, not just read, it will stop the flow and say action is required. You are about to make this query. This is our way of showing it, but you can show the UI however you want. If you're the user cannot understand SQL, it's fine. You can show in another way. But so you're about to make this action. Only if you approve will I continue. There you go. Issue has been requested. Called like a mocked Stripe API to do that. So imagine the possibilities, right? Connect any API, connect any data source, however many APIs, however many data sources, and you just have an extremely, extremely intelligent and powerful LLM application to do stuff for you. Okay, to show you the logs. Any other questions? Yeah.
I have a couple. If I wanted to see this run with my company's data,
Yeah.
is there a way to do like a trial?
Yeah, for sure. Yeah, let's do that. So using the instructions in the hackathon, you can literally get started today yourself. But because like we aren't really public yet with this, so if you want direct support with our engineers, we can set that up as well. So I don't know if you got a chance to open this document.
Thank you. And then my other question was, we're a payments company, so we have a lot of PII that we don't want to make public. But I hear that you're saying that it's LLM agnostic, so it would depend on, so I have the choice of picking what LLM I'm
100%, yeah.
And is there a way to, is there a way to use an LLM that would be private to us?
Yeah, use a self-hosted Llama 70B
Llama.
instance.
Okay.
And
That would be your own personal LLM?
own personal LLM. Even the AI server runs on your machine.
Okay.
Everything is on your machine. Nothing is on.
So we
any
can't
cloud.
keep it private using this?
Yeah.
Okay, thank you.
And you can just use the, don't even have to use this UI, have your custom UI, just use the PromptQL layer, maybe just use the AI layer, whatever is the best for your team. So literally here, if you change your, like I'm using this some Postgres data I've hosted, right? You can use your own Postgres database or any other database for that matter. We already have connectors to, already have connectors to all of these databases. All your popular ones, Postgres, ClickHouse, Mongo, MySQL, Snowflake, Oracle, all of these we have. We are rolling out support for these very, very soon. And then we are also rolling out support for a bunch of SaaS APIs. So Zendesk, Salesforce, GitHub, things like those. Slack, email, Gmail, Google Drive, whatever. Yeah, whatever.
I didn't get the QR code.
Yeah, for sure.
Our team doesn't own a DB. Actually, we have upstream team send our data directly to us. Do you know how that will be integrated to our to use your if we don't use a DB at all?
Upstream what, sorry? You don't use a database, but?
Yeah, so we are like an API of API, so we have upstream team sending our data. So when people call our API, we just send another request to our upstream teams and get data from their DB. So, but they have separate DB on their side, which we cannot implement on their side. Do you know how you could handle this situation?
Yeah, so basically you're saying you don't have direct access to the database. Maybe they have exposed an API on the database that you need to connect here, right? To this LLM.
Yeah, that's right.
Okay, perfect. So what you can do is just basically write your own TypeScript connector. For Zendesk, what we did was wrote a TypeScript connector. So the Zendesk API is connected to Hasura via a custom TypeScript connector. So just follow the docs here, and you can write your own connector, and that will get you up and running. So I have all of these links in the doc as well. So if you go at the bottom of the doc, this is the Hasura DNA documentation. To answer your question, if you want to set up a call with our team, you can get a personalized setup. Just go to hasura.io/promptql, and we can get a call set up instantly. You can directly reach out to me. That's my email, anushrut.gupta@hasura.io, or my LinkedIn. Find me on LinkedIn, ping me there, anything works. So we can get those calls set up. Now to answer the logs question. Who asked me the log question?
A lot of questions from me.
Okay. Yeah. So basically, if I would have run this in the debug mode, so basically this is the server running, right? So you see every token, so every LLM call that's happening, although we are also logging every user query that's happening, every PromptQL code that's getting generated. So if instead of doing this, if I show you, if I don't use the UI, if I use the CLI, I have this instruction here as well. So let's use PromptQL CLI. Let's do that. Okay. What are the top 5 invoices? Okay. So literally all of this is getting logged, which is what did the user ask, what was the first assistance response, what input did the tool get, what was the Python code, what was the SQL query, what was the SQL response, what output came out of the tool, and then what did the assistant respond with.
There is the content entry.
Oops.
Oh, I'm just like getting there.
Oops. Those are our engineers who are standing by if you have any questions. Yeah. Okay. Um, any other questions? Does that answer the question though?
Yeah, right. Yeah.
Yeah.
You measure quality, like what's the quality like?
Quality of response, that's a great question. So what we are working on is basically an eval benchmark, but nothing like this exists today. So we have to write custom benchmarks for now. So what we have is something called golden query plans, so which is like populated, like let me show you. Let me show you for the GitHub one. So literally, like these golden query plans, like what can a user potentially ask? Like show issues in this specific repo with the server enhancement labels, but not the easy and long-term labels, like these kind of complicated queries. And what do we expect it to do? Something like that. So, but this has to be like manually verified, right? Like it's tough for us to do. Like we are also thinking about a benchmark on the artifacts piece, like these artifacts that you see, because these are more structured and you can do more structured benchmarking on that. But on the LLM responses, you have to do it more manually, right? So we have these benchmarks for these common use cases that we're working on. So, and it's performing really well on those. But yeah, we're trying to figure out how to do like a public benchmark with some public data set. But if someone else were doing the same thing, it would have been easier. But yeah. More questions?
Let me my understanding more deeper. So you basically so your summarization or query is just kind of function. So right. So you create some function calling. Is that what you do? Right?
Yeah. So basically, it's technically function calling, but there's only one function, which is you have access to a Python tool. You have access to a Python runtime. Go crazy with it. That's the only function of the LLM. Why? Because LLMs get insanely confused if you give them more than 20 functions. Try to give them more than 20 functions. They won't pick the right function. They will not pass the right parameters. Give them one function, and without any, like, you have the capability to write Python code. Go crazy with the Python code, no matter how big it is, no matter how complicated it is, how many steps it has. It's totally fine.
Is that the code is in Archer repository, right? No?
Which code, sorry?
So you put it in Archer. This kind repo in docs.
Yeah. So
Is there in actually Python code in Hasura Archer, right?
yeah, exactly. Yeah. You can go and check it out. Exactly.
Oh, I see.
Yeah. See how it has been prompted. See, just,
Very good.
yeah.
Another not question. So when you use do you have to make a service call like to your AI, like OpenAI, like when I use chat GPT, I have to connect to their like server to make service call.
That's what we did here, right? Like when we like in here, right here, you see, right? You're passing your Anthropic API key, right? So you were talking to Anthropic. You can just and here you can just do hyphen. Oops. Hyphen. Oh my god. Yeah. You can do hyphen LLM and then open AI. If you just do by default, it uses Anthropic. If you do this, it'll use OpenAI, and then you just pass your your
So we are making a service call to the AI basically.
yeah, exactly. Yeah. I mean,
So in that case, how can I make sure that my data doesn't get released to them? So like I don't want our data to go to another company.
so if you want to build an AI application on your data, you have to give AI your data, right? That's fair. So either use an LLM on your own premise, so use Llama or something like that, so that you have complete control over it. Or if you want to use one of these services, I mean, they promise these enterprise-grade private cloud compute, right? Both OpenAI and Anthropic have that. If you trust them, you trust them. But majority of the data moving and the data processing, it's not going to the LLM. It's happening in your Pacha runtime, like in this Python runtime that's happening, right? That's hosted on your machine. When this Python code is executed, where is it? This Python code is executed. That's not getting executed at OpenAI's on OpenAI's server, right? That's on your server, and that is handling all the data. And if you look at this, like the LLM is just passed like this 2-3 top rows of the data, not the entire, like, because if there are 20,000 rows that you just retrieved and processed on, you can't pass all of that to the LLM, right? So you give it a sliver of data to get an understanding of what the output was, and gives you a natural language response. But actual data, all of this is all local to your server. But yeah, feel free to use, even if you don't want to send that sliver, you don't want to send your schema to them. That could be a fair concern. Use your own LLM, right?
Yeah. Thank you.
More questions? Oh, okay. Great question. DDN is the data delivery network, which is Hasura's basically core product, which allows you to build instant APIs on your data sources. So instant GraphQL APIs, instant PromQL APIs on your data sources. So yeah, I'm so sorry about that. Yeah.
Just out of curiosity, I see they are making a videotaping this. Will this be published somewhere? Do you know?
I would let the organizers answer that, but yeah, I think so.
Publishes it to their YouTube channel.
Okay. Nice.
Yeah. Thoughts, comments? Exciting, not exciting? Seen this before?
How many of you all have AI goals or AI use cases that you want to deliver on this year or early next year? Is this something that you're working with?
Sorry?
I think he's asking for a roadmap.
Yeah, like basically, are you guys building AI products, like AI tools? And you said that you wanted to work on something, right?
Yeah, I think we need this thing. So we have our own LLM in Amazon. Yeah. So very interested in. We currently use our it allows to monitor the queries, like top 5 queries we call. This will be very helpful to our customer.
Yeah. Please feel free to shoot me an email. Can we also note the, yeah. So you can reach out to us, we will reach out to you, and yeah, we can set up a call, discuss the use case, and see how we can get this going. Yeah, would be very exciting if all of you could try it out and share feedback, share thoughts. Like it's a fundamentally new approach of connecting data to your LLMs, which is actually useful and can be really powerful in real enterprise use cases. Make a personal tool. Connect your Gmail, your calendar, your Slack, your, I don't know, WhatsApp gives an API or not, but yeah, connect these things. Create your own personal assistant. Awesome. We still have 29 minutes. Feel free to stick around, ask questions, do a deep dive, reach out to us. That'd be great.
Awesome, thank you.
Of course. Thank you so much. Thank you.
Give us the right time. When you folks tried the GraphQL approach, was the quality really bad that made you like do PromQL?
Yeah, the first thing was.
Like I get the aggregation
GraphQL.
side, like that's very obvious.
Yeah, so basically, LLMs are not that good at generating GraphQL altogether compared to SQL.
That's where the tuning can really come in, right?
No, I completely agree. But then, yeah, you can fine tune, sure. I agree. But then you can't really do anything more than just data retrieval.
Yeah.
Right? And that to just like one shot data, like one time data. follow-ups I can't do. Right? Like if I say, it's connected to my high school, a teacher asks, okay, what is the average score for my last test? Simple question. Average score, I have each student score. There are 2,000 students in my school. How will a GraphQL query able to answer that? Like, it can't. So you need this analytical brain for the LLM. So now you can argue, can you do Python plus GraphQL and not Python with SQL?
Yeah, no.
That's a good
See,
question.
Even like SQL, like that's a part. The SQL's not going to get you there because I think we've tried like SQL and we had like really bad quality even just with SQL. So what you're doing is like slightly different. Right? You're doing SQL plus Python basically.
Exactly. Just do SQL, it won't work.
It won't work.
Yeah. And plus you limit the scope, right? Like SQL is just for getting you the data. That's all. Python is where you process the data and do operations on it.
And are all those things that you're doing like within Python, like are they basically like custom written functions for use from you folks, or are you doing like anything just with like NumPy or Panda?
Oh, Pandas is not even installed in the environment, but we should, because basically just give it all the libraries in the world and it'll do everything. Yeah, we're gonna do that. Like it's like a baby right now. It's already pretty powerful as a baby. So imagine when it evolves what it'll be. Yeah, like we just want to give it all the libraries. Like imagine give it matplotlib seaborn.
Yeah.
Ask it to do visualizations. Just
That's my point, because I think if it's custom written, you are basically like swimming against a big tide also at that point, right? Because you in the example that you're taking, like, I want now generate like visualization, then you're like basically like coming up with like very much of visualizations as opposed to
yeah.
in the library.
Yeah, correct. So it's the only thing custom right now is I would say these primitives, this classify and summarize primitives to call another LLM. That's the only thing which is custom right now. Everything else is.
Why is that custom? I'm curious.
You can give it a free reign access to another LLM. You can do that, like if you need, but then it will not really call that LLM ever.
But you can still do prompt to the LLM for summarization as well. Like, why is that custom?
No, custom in the sense that this, like, summarization and classification are the two biggest tasks that you need to do with an LLM, right? So to have their performance the best, have a structured way of doing it. Like, okay, define categories, define instructions, and then execute it. So just giving that some structure as a primitive versus saying, okay, here you have access to an LLM, go talk to it if you need to do anything. Sure, you can do that, but again, performance will suffer.
Yeah, I mean, like, it's all going to come down to quality and benchmark.
Correct, exactly. And yeah, and we also picked just these two primitives because of the use cases we were seeing. Like if you want to see, okay, what label should I put on this GitHub issue? That's a classification task, right? Is this customer support ticket important? That's a classification task. So like, you can word it in multiple ways, and under the hood, it's just a classification task or a huge ticket. Like, can you explain what's happening in this email chain? That's a summarization task. So basically, you do two key tasks with LLM. That's summarization, classification. So that's why we picked these two as primitives.
Thank you.
Can we take? Yeah, are you? If you're building any AI applications, would love to. And Praveen.
No, nobody's fine.
No issues, guys. 100% smooth.
What?
No issues.
Are you sure? Like, there's like not required?
Yeah, honestly, if you don't come now, it's fine. Like it's over now.
Okay.
Yeah.
But, like, were there any issues?
No issues, absolutely none.
Oh wow, amazing, dude.
Yeah.
People are able to try it out. Like people are able to try it
Yeah.
Amazing.
Yeah.
Amazing.
And
Okay.
great. I'm still there, but I'll come back and then give you. Okay.
Cool. All right. Then I'm just like walking back to the office.
Okay. So sorry, Vamshi.
No worries.
Yeah.
No. I like now I remember you said like JW Marriott. I'm like I was wondering like what is that JW thing? Now I realized that there are two Marriotts in like 4 blocks.
Yeah.
All right. Cool.
Okay. Thanks, guys. Bye. You can also drop over now.
out.
Right. Thank you. Bye.
this is exactly Python code, right?
Yeah.
Oh, I see. It's cool.
You like the